What's going on? This is SDG Labs. My name is Anastasio Dalde. Let's do some math! This is actually introducing you to a different set of notation, and you probably learned how to do this in elementary school. So it's kind of important that I show it to you, but it should be familiar with you. Here's 0, 1, 2, 3, 4, negative 1, negative 2, negative 3. And this graph looks like this. And this graph looks like negative 3 and beyond. All right. So, how would I describe this? And this is really just a matter of notation. You could draw it graphically. Here's the graph. You could tell me, hey, which values are allowed? Well, any values that have the blackened outside and beyond. So like if this is 2 and this is negative 3, so like 3, 4, 5, 6, 7, all the way, all of those guys are there. And then also negative 3 and beyond. Maybe I should make this thing a little bit longer. There we go. All right, another notation, and I just described for you in words. Or actually more accurately, maybe I'll describe it for you in words. I don't want to write it up, it just takes too long. But x such that x is smaller than negative 3 or bigger than 2. Notice how I actually kind of tripped myself up there because I said and, but wait a second, no, it's not and, it's or. Because if you think about it, how can you have a number that's smaller than negative 3 and bigger than positive 2? That doesn't make any sense. It has to be the word or. Because there is no number that is smaller than negative 3 and bigger than positive 2. Unless your number line is a big circle. But, you know, that's a different kind of math. All right. If we want to use this thing called set notation, you would use those little curly brackets that I did. And you would do x such that. That's what the double dot means. It's x such that. And this is really just kind of identifying the variable that I'm going to be working with. X such that x is smaller than negative 3 or x is bigger than 2. And what you would do is you could put the equal to sign as well because these dots are full. If these dots were open, that means it's smaller than negative 3 but not equal to negative 3. Same thing with it over here. All right, one of the things I like doing is this thing called interval notation, and it looks like this. The allowed x values is anywhere between negative infinity and, because negative infinity is way out here, and negative 3. So it's negative infinity, comma, negative 3. Union, wait a second, 1 second, sorry. My computer fell asleep on me. I'm working out all this technology, I promise. Oh, I'm almost going to drop the binder. There we go. Trying to juggle everything. All right, here we go. Union, this is an or statement. 2 and infinity. It goes all the way up between 2 and infinity. Now, where do I put the brackets? Well, this one's going to have a bracket instead of a parentheses because it's an equal to sign. This one is going to have a bracket as well instead of a parentheses because it's an equal to sign. But the infinities, this positive infinity, this negative infinity, they never get brackets. They always have parentheses because you can never reach infinity. You can never go all the way up to infinity. So we just leave it as a bracket. Shoots, bro. Up out.